Precalculus, Chapter 1.2, exercises 47 through 62. In this first set, exercises 47 through 54 state whether the function is odd, even, or neither. Support graphically and confirm algebraically. Well, first thing I'm going to do is explain what definitions of odd and even are. So for an odd function, if we have a function f of negative x, that's going to be equal to negative f of x. And what that's going to look like graphically is we're going to have what they call symmetry about the origin, but I think it explains it better if we say we have 180 degree rotational symmetry and that's going to be symmetry about the origin. And we're going to see what that looks like. And then for even symmetry of function, for even functions, the textbook definition is if we have f of negative x, that's going to be equal to f of x. And effectively what we have for this one is reflective symmetry about the y-axis. And we're going to examine, first of all, problem 47. We have f of x equals 2x to the fourth power. So to graph this function here, we draw a xy coordinate plane. And what this looks like is it's almost like a parabola coming down here, except that parabola smashes a bit flatter against the x-axis and comes back up kind of like this. And graphically, we should see that the graph appears to be a mirror image about the y-axis. And so graphically this looks like an odd function. But let's go ahead and put this in our calculator to see what it looks like. And so we put in 2x to the fourth power, and we graph the function here, and this is what it looks like. So it's kind of like a parabola but smashed a little bit flatter against the x-axis. Well, we're going to go to the table view and we press second graph, and what I want to do is come right here to where we see 0 right in the middle. Now remember what the definition of an even function is, that f of negative x is equal to f of x. Well, in this case we have f of negative 1 is equal to f of 1, right, which is f of x. F of negative 5, 1250, is equal to f of x. So this meets the definition both graphically and algebraically of an even function. So we say even symmetry. So that will be our answer to problem number 47. Now in this exercise set, I'm going to go over all the odd number problems and leave the even ones mainly for the viewer. So I'm going to skip here to 49. So we have this one, f of x equals the square root of quantity x squared plus 2. And to me, the function does not look to be, I can't really get its symmetry because I'm not really that familiar with that type of function. So what I'm going to do is go to the calculator and just put it in there and see what we get. So we have the square root of quantity x squared plus 2. And when we graph this function, if I go to zoom 6, this function does look like it has symmetry about the y-axis, so it would be like even symmetry. That's what it looks like to me. But to be sure, let's go to the table view, and if we look at the table view, do we see that f of x is equal to f of negative x? Yes, these are the same. 1.7321 is for negative 1 and 1.7321 for 1. So they are the same. So for this one, so that would be an algebraic confirmation. So right here at the square root of, if you plug in 0, you get the square root of 2. So it's going to come like this and be kind of like a flat curve. So we say even symmetry for this one. So we found graphically and we confirmed algebraically through the table. Next, another problem 51. We have f of x equals negative x squared plus 0.003x plus 5. Let's go again to the calculator. We have, sure, we get negative x squared. So negative x squared plus 0.003x plus 5, and we graph this function here, and this graph function has every appearance of having reflective symmetry about the y-axis. So just graphically, I would say, yeah, this looks like a function with even symmetry. But let's go to the table view here, and if we look carefully, f of negative x, in this case negative 1, is 3.997, and if this is an even function, f of 1 should be exactly the same. But we see that they are apart. They are 6/1000ths off. We subtract. So they're not. This is close to a function with even symmetry, but not exactly even symmetry. So we say neither. So again, this is an example where we have to watch closely. And this is one of the areas where a test writer will try to fool you. So just be ready to check to be sure. And it's this plus 0.003x that does it, because if it weren't for that term, we would have definitely even symmetry. Next, 53. We have g of x equals 3x cubed minus 3x. And just because I like to do such things, I like to find a common factor. So if we have 3x, a common factor to both of these terms, times quantity x squared minus 1. And we can further factor this quantity x squared minus 1 to be quantity x plus 1, x minus 1. So when we graph this function, we're going to have our zeros are going to be x equals 0, x is equal to negative 1, and x is equal to 1. So if we go ahead and mark our x-intercepts at negative 1, 0, and 1, and this is a positive function, this is going to look like this. Okay, so that's basically what that function looks like. And what kind of symmetry is this? Well, definitely not even symmetry. I'm going to try to do a little trick here with my smart technology. And if we spin this around, okay, you can't see it exactly, but this is 180-degree rotational symmetry. Because we spin it right about the origin, it spins upon itself. But let's go to the calculator to be sure. We're going to have 3x cubed minus 3x, and see what this looks like. We're going to see, okay, that looks like it is rotational symmetry. Let's go to the table view to be sure. So what we have is f of, we just go to -2, f of negative x is going to be negative 18, which is negative f of x. So if f of x is 18, negative f of x is negative 18. And so this is the type of pattern we see with odd symmetry. So we'll say definitely odd symmetry. Now, one thing that you may notice over time is that you have the highest power of this polynomial is to the third power, which is an odd number. And if you look back at number what's the first one we start with? 47. We have an even power. And so you're going to see some correspondence that way. Okay, as for 54, I'm going to quickly explain that this 1 over x is the same as x to the -1 power, if that gives you any kind of clue. Let's go on to this next exercise set, which is exercise 55 through 62. Use a method of your choice to find all horizontal and vertical asymptotes of the function. Well, I'm going to look at the vertical asymptotes first. The only way you can have a vertical asymptote is by having the denominator equal to 0. So to find our vertical asymptote for this function here, what we're going to do is set denominator equal to 0, and then solve for x. So here we have our denominator. We set x minus 1 equal to 0. And we solve for x. X is equal to 1. And so our vertical asymptote, which I abbreviate VA, is going to be x is equal to 1. Now in this case, we don't have, if you have a discontinuity, it's possible that we could have a cancelable discontinuity, which would make this a removable discontinuity and not a vertical asymptote. But we don't have any cancellation going on here, so that's going to be our vertical asymptote. We're going to verify graphically here in a minute. Now for a horizontal asymptote, what that is it's going to be y equals the limit as x approaches plus or minus infinity of f of x. And the way we find this in the case of you take the ratio of the powers, the highest powers of x, both in the numerator and in the denominator, and any lower powers you ignore. So this 1, this minus 1, which would be 1x to the 0 power, we ignore that. So what we're going to do is we're going to get y is equal to x over x, which simplifies to y is equal to 1. So our horizontal asymptote here is going to be y is equal to 1. And graphically we're going to show you what that looks like. So going to the calculator, we have x over x minus 1. So we get our x over x minus 1, and we graph that function here, and we should be able to see a vertical asymptote at x equals 1. I'm going to go to place this on a grid line, to get a better look at it. Then we're going to go to table view. So we see that faint vertical line at x equals 1. We go to table view, and we see, whoops, we're going this way. At x equals 1, we have an error. Now, remember we said the horizontal asymptote is y equals 1. Well, if we go to table set, I'm going to pick a very large number, say maybe 100, because if we go out towards, I'll even put 1,000. If we go out towards infinity, in this case I'm using a very large number of 1,000, we should be able to see, I hope, that we'll be approaching 1. Well, here we have at 1,000, we have 1,000 over 999. And so I hope you can see that if we got up to 1,000,000, we would have 1,000,000 over 999. So approaching 1. And we'd see the same going the negative direction. So that is some corroboration. Let's go on to the next ordinary problem, which is 57. So our vertical asymptote, we're going to find where our denominator, our function is undefined, and that's going to be where our denominator is equal to 0. So if we put 3 minus x is equal to 0, and we add x to both sides of this equation, we're going to have 3 is equal to x. So for this one, our vertical asymptote is going to be the equation x is equal to 3. And for the horizontal asymptote, it's just kind of what we were looking at earlier in problem 55, where we have the definition of our horizontal asymptote is going to be y is equal to the limit as x approaches plus or minus infinity of our function, in this case g of x. So for us, we're going to have y is equal to, we have x, and we're looking for the highest power of x. In the numerator we put x, and then in the denominator we have negative x, which is going to be y is equal to negative 1. So our horizontal asymptote is going to be the equation y is equal to y is equal to negative 1. And for corroboration, okay, x plus 3, 3 minus x, we should see the same thing. So we have x plus 3 in the numerator. In the denominator we have 3 minus x. And we graph the function. This is what we get. A vertical asymptote at x equals 3. And then if we go to table view, and remember I think I had it set table start at 1000. Okay, look at, we have negative 1003 over 997. And the farther out you get, the closer you're going to get to negative 1. And the same thing for going the negative direction. Remember it said plus or minus infinity? Let's go to table start of negative 10,000. Okay, what are we going to get here? Should get negative 1 also. In this case, negative 0.999. So negative 1 is our, y equals negative 1 is our horizontal asymptote. Okay, next we have 58. Q of x equals 1.5 to the power of x. Now, first of all, for vertical asymptote, I was going to go to the odd number problems. For vertical asymptote, do we have the function undefined for any value of x? No. So there are going to be no vertical asymptotes here. I'm going to go on to the odd number, which is 59. So in this case, we have f of x equals x squared plus 1 over x squared plus 2 over x squared minus 1. So for this one, we are going to have, if we factor our denominator, we are going to get quantity x plus 1 times quantity x minus 1. And if we set this, we set quantity x plus 1 times quantity x minus 1 equal to 0, solving, we're going to have x is equal to negative 1 and also x is equal to 1. And so if we don't have any cancellation, and then the numerator x squared plus 2 appears not to be factorable, so we should have, in this case, a vertical asymptote, two of them. We're going to have x is equal to negative 1 and also x is equal to 1. So those would be our vertical asymptotes. Now how do we find our horizontal asymptotes? Well, it's our horizontal asymptote is going to be the limit, or let me say this way, y equals the limit as x approaches plus or minus infinity of f of x. And for us in this case, we're going to have y is equal to, now what we have to do is take the highest powers of x, both the numerator and the denominator, so we're going to get x squared over x squared. And why do we ignore in the numerator this plus 2 and the denominator this negative 1? Well, the reason is because as we approach infinity, this 2 in the numerator and negative 1 in the denominator are going to fade into less and less significance the farther out we go. And so our limit for this, or horizontal asymptote, is going to be y is equal to 1. So let's go ahead and look at our graphing calculator again. Okay, make sure we have here x squared plus 2 over x squared minus 1. X squared minus 1. Okay, that looks good. Graph. Okay, it looks like we have two vertical asymptotes. And if we go to the, well, I'm going to go to, let's do this. I'm going to go to second table set. I'm going to go to ask here. Change this auto to ask. We'll be able to put in custom numbers here. So we go here, we press at -1, we should get an error. At 1, we should get an error. So those would be x equals -1, x equals 1. And then if we can put in a real large number, we should get to 1. So if we put in, that's 100,000, we'll make it an even million. Enter here, we get 1. So the rounding off gets to 1, exactly, which we calculated was our y equals 1. So I'm going to -10,000, see what we get here. We also get 1. So going, the limit as x approaches positive infinity and negative infinity is 1. Alright. The next one I'm going to work out here is this one, g of x equals 4x minus 4 over x cubed minus 8. Well, for our vertical asymptote here, we are going to take our denominator, x cubed minus 8, and set that equal to 0. So adding 8 to both sides of this equation, we're going to get x cubed is equal to 8. And solving, we can take the cube root of both sides of this equation. So that's a cube root of the left side and the cube root of the right side. We have x is equal to 2. So that should be our vertical asymptote. So I'll put down vertical asymptote, x is equal to 2. Now we're going to check that pretty soon. And that's going to be the case if we don't have a cancellation. Now, in our numerator, we can factor out a 4 from each term. So we can have 4 times quantity x minus 1. And if x minus 1 is not a factor of x cubed minus 8, we know that we'll know that we still have preserved, and that's definitely not going to cancel the 2, so that'll be right. So we can check quickly with synthetic division and put the 1 out here, and then put 1x cubed, 0x squared, 0x, and -8. So if we don't come out with 0, we don't have a factor. So 1 times 1 is 1, 1, 1 times 1 is 1, 1, 1 times 1 is 1, -7. So our remainder is not 0. So we're not going to have, so we're pretty sure that our vertical asymptote of x equals 2 is good. Next, we got x cubed minus 8. Next, for horizontal asymptotes, okay, y is equal to the limit as x approaches plus or minus infinity of g of x. And now I'm going to work below here. So we're going to say y is equal to, we take the highest powers of both the numerator and denominator. So in the numerator we have 4x to the first power. So that I'm just going to put that as 4x. And in the denominator we have the highest power is x cubed. So we're going to have x cubed. And so when we simplify this, we have the x. The x is going to, one x is going to cancel out, so we're going to have 4 over x squared, which is going to be 4x to the 0 power. And so the 4, and this is an example of bigger on bottom. If you have the power bigger on bottom, we are going to go to 0. So our horizontal asymptote is going to be the equation y is equal to 0. And now we're going to check in the calculator. So we have 4x minus 4 delete over x cubed minus 8. So we change that cubed in minus 8. Okay, let's see what this looks like. I hope we have our vertical asymptote at x equals 2. Yeah, that's pretty good. And look what happens here along the x-axis. We're really at 0. So we go to, if we go to, so we kept the same numbers in here. Let's put in 2. We get an error, so that's a vertical asymptote. And then we have 1 million. We get 4e to the negative 12 power. That is 4 trillionths. If we put in negative 10,000, we get 4 times 10 to the negative 8th power. That's going to be negative. That's going to be 100 millionth, 1 over 100 million. So yeah, that checks out. So these would be our correct answers. So really we looked at solving all of these algebraically, but confirming graphically, and also using the table numerically. And then 62 is this one here. I think your horizontal asymptote also is going to be 0 for this one. Anyway, I hope this has been helpful to you. Good luck, and thanks for viewing.